So here's example 3 of improper integrals. Have the integral from negative infinity to 0 of e to the 1 over x squared. The one thing I will notice is that I have a negative infinity here that I have to take care of. That's improper. But also, 0 becomes an issue here, because if I plug in 0 in there, I end up dividing by 0. So I have to take care of that too. So that will necessarily mean I have to put these into 2 parts. So I'm going to have to break this up in the middle somewhere. It doesn't really matter where. I'll pick something between negative infinity and 0, so we'll do negative 1. And then I'll do the last part. Oh yeah, also I didn't say this, but I have 0 here that I'm dividing by, and I also have it here. So I actually have it in 2 places, but in any case. So let's do these separately. These both are the same integrand, so I'm going to have to do them the same way. I'm just going to do them one at a time now. I notice 1 over x here, and a 1 over x squared, which is kind of like its derivative. But I'm off by a minus sign, that's okay. I'll do u equals 1 over x du minus 1 over x squared dx. I can throw that negative sign out front. And I'm not going to write an equals sign here because I'm doing them one at a time. So I'm going to label it first integral. You will lose points if you write an equals sign here and only do the first one, because then you're saying this whole thing is equal to whatever you write there, and it's not true. So the first integral is negative. I'm going to do it in another color. Integral x goes to negative infinity and x equals minus 1. I'm specifying because I'm not changing my bounds. And I have e to the u, and then the x squared dx, x squared on the bottom, and the dx goes away and becomes du. So now I've got negative. Now I can just do the limit. Limit as b goes to negative infinity, integral from b to negative 1 of e to the u du. And that, I'm going to just draw an arrow. That's negative limit. B goes to infinity. E to the u goes to e to the u, same antiderivative. And I've got e to the minus 1 minus e to the b. And then b is going to negative infinity here. So that's negative limit b goes to negative infinity of e to the minus 1, and then e to the negative infinity, that's 1 over e to the infinity, which is 0. So that's minus 0. So there's negative, and then 1 over e. So that's the first part. I'll do the second part in another color. I have the integral from minus 1 to 0 of that. I actually already have. Oh shoot, I did something wrong here. I did e to the u. I've got to do e to the u, but I have to sub back in x. Keeping this in the video so you can learn from me. I'm going a little too quick. E to the u, and x is b, and x is minus 1. Then I got to plug back in 1 over x. From b to 1, that becomes limit b goes to negative infinity of e to the 1 over 1 minus e to the 1 over b. Take the limit, b goes to negative infinity, I get e. 1 over negative infinity is 0, and e to the 0 is 1, so I get minus 1. Lesson learned. Last one. I have to take the limit on the other side now. Limit as b goes to 0, integral minus 1 to 0 of this. See, I even did it again. I forgot a negative sign here. This negative sign is negative e minus 1, so it's 1 minus e. Sorry about that. Hopefully it's not making the video confusing. I'm hoping you can see where I went wrong. So I've got to take this integral from minus 1 to b of that. Thankfully, I already did this integral, so I'm not going to do it again. It's minus e to the 1 over x from minus 1 to b. See, I just screwed it up again. I can't believe I'm doing this. It should be b to negative 1. I just didn't copy over the minus 1. So it should be e to the minus 1. Should be 1 minus 1 over e. Now we're good. Pardon me. So should be, can continue with this, limit b goes to 0 of negative e to the 1 over b minus e to the minus 1. And now what should I do with this? Well, I have to figure out what's going on here. So I'm going to isolate this. I'm just going to write it separately. Negative out here, I'll pull that out. E to the 1 over b. And write this on the side so that I can think about this a little clearer, because it's written by itself now. I have 1 over 0 we know goes to either plus or minus infinity. If it goes to plus infinity, then I have the e to the infinity and the whole integral diverges. But if I have negative infinity up in the exponent, e to the negative infinity goes to 0 and it converges. So I have to figure out which one it is. It's not d and e, it's not infinity. I have to figure it out. The answer lies in the bounds of the integral. The integral goes from minus 1 to b. So the integral is going this way. So I'm actually approaching b from the left. So I've got to include that 0 from the left. Now 1 over 0 from the left goes to negative infinity. So that'll be e to the 1 over 0 minus, how would I write that? I would write e to the 1 over 0 minus 1 over e. That's negative e to the negative infinity. Negative 0 is just 0, and I get negative 1 over e. So, what was my original integral? It was the sum of all of these. So I got to add these. 1 minus 1 over e plus minus 1 over e. So the integral e to the 1 over x squared equals minus 1 over e plus 1 minus 1 over e. So it's 1 minus 2 over e. I decided not to redo this video with a couple mistakes because I think it's a better decision, and hopefully you can rewind and piece together what went wrong. But apart from that, I think that should be it.